Okay, in this video we'll talk about what it means to have continuous compounding. In the previous sections of 3.1 we compounded a certain number of times per year. Now we're going to talk about continuous. Now in order to do this we're going to get a new formula, and this formula is given as your amount as a function of time equals your principal amount times e to the power of r times t. So in this case p is still the principal, your initial amount, principal. R is the rate as a decimal, so don't leave it as a percent. And T is time. Most often in years, if R is a rate in something per year, then T would be time in years. So time is related to the rate. All right, so let's go ahead and do an example. Oh, and E is just a number. It's kind of like the number pi. So if you take a look at a calculator, so here's my Desmos Scientific Calculator. Over here where it's main, there's ABC, and then there's function, or func for function. You'll see that I can click down at the bottom there, there's an E. E is about 2.718, etc. Just like pi would be 3.14, E is 2.7. So let's go ahead and solve a problem. So let's just say you invest $100 in an account that grows continuously at, let's just say, I don't know, 3.51%. How much money do you have after, let's just go with, I don't know, 17 years. Okay, so here we go. So you have this investment. We have a rate, we have a time. So we'll go ahead and plug this into our formula. Our amount after 17 years is going to equal 100 times e to the power of 0.0351. This times 17. Let's go ahead and use the calculator to solve this. So I'm going to go back to my main section, 100. Now I'm going to use e. Notice I could do this e and then do something over here with to the power of. So you can do it that way, or you can use the e to the power of x and it automatically gives you that. So once again, if you look over here where there's this log and then ln, and then above the ln is e to the power of x. So I'm going to use that. And then I'm going to go with 0.0351 times, and it would help if it stayed up there, so I think I'm going to use some parentheses, 0.0351 times 17. And so I'd have $181.61. And that is how you do continuous compounding.